We've so far talked about the network layer's data plane, which is about the content of packets and how those packets are compared against forwarding tables and flow tables to get the packet delivered to the right place. Today, though, we're going to talk about the control plane, which is how those forwarding or flow tables get installed in the first place. That is, if a packet needs to get from this laptop to this server, say, and it reaches some router here in the middle that has multiple ways out it could send that packet, the router is going to compare that IP address probably to some prefix-based forwarding table, match it to a particular line in this table, and use that to select which wire it should send that packet out. But where does this table come from? How does it get configured? And how do we deal with the fact that the internet is always changing? Hosts appear and disappear, whole subnets appear and disappear, and connections between different networks appear and disappear. This is going to turn out to be mostly a refresher and dive into some algorithms on graphs. If we have a set of routers that are connected in various ways, those routers can reach the things in their subnets easily enough, but there's a real question of if we want to get to a machine and use subnet to Z's subnet, which path should we take through this network? Especially because in practice there will be better or worse choices to go through based on how many hops we have to take, the characteristics of the links, how loaded they are, and so on. We can boil this down to the question of finding the best path through a graph to get from one node to another, where the edges in the graph have weights, and we say want to minimize the weight of the path that we take to get from one node to the other. So for the moment, let's forget about the idea that these are routers and just consider generic nodes in a generic graph with weights on the edges of the graph.